4.5 is on graphing sine and cosine functions. Alright, here are the quadrant angles of a unit circle going from 0, pi over 2 pi, 3 pi over 2 to 2 pi, right? You have 1, 0, 0, 1, negative 1, 0, 0, negative 1. Recall that your cosine are your x coordinates, right? And sine theta are your y coordinates. Let's go ahead and make a table for y equals sine of x. For your input, right, notice that we have angle measures here, so we're going to go ahead and put 0 radian, pi over 2, pi, 3 pi over 2, and 2 pi. And notice that from here it's going to repeat itself because, its coterminal angles are repeated every 2 pi. So remember, for sine, it's the y coordinates, so my y coordinates will be 0, right, when sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, and then sine of 2 pi is again 0. I went ahead and labeled the x-axis using 0, pi over 2, pi, 3 pi over 2, and 2 pi. And let's go ahead and label the y-axis. We're going between 1 and negative 1, so I'll go ahead and mark that there. Now if I actually plot these points, I get 0, 0, pi over 2, comma 1, pi, comma 0, 3 pi over 2, negative 1, 2 pi, comma 0. So I went ahead and made a smooth curve going through the points, and this is the basic shape of my sine curve. Notice that we go through an intercept, then we have a maximum point, we go through an intercept, the minimum point of the graph, and then back to the intercept again. So we have 3 intercepts for a sine function. And again, these are going to repeat, right? Because sine theta, right, or sine of x, right? The values are going to repeat every 2 pi, like every one full revolution, or every 2 pi radians. Your y values or your sine values are going to repeat. So you're just going to keep having these curves here. It goes on forever in either direction. But this one little section here, that is called one cycle or one period, because that's a little piece that repeats itself. What would happen if I made this a negative sine of x? What would happen then? Right, that would be a vertical reflection or reflection over the x-axis. So, right, it would just flip over like so, right? So that would be negative. You would go minimum, intercept, maximum, then intercept, instead of max and then min. Okay, now let's go ahead and do the same for y equals cosine of x. Again, note here that your input is your angle measure and your output is the ratio. So cosine of x, if you remember, Kickster, right? In a unit circle where radius is 1, cosine is your x coordinate, so we get 1, 0. Right, cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1 again. Okay, I went ahead and labeled my x-axis and my y-axis there. So let's go ahead and plot these. Again, I have 0, comma 1, pi over 2, comma 0, pi, negative 1, 3 pi over 2, comma 0, and 2 pi, comma 1. Okay, and here I went ahead and drew a smooth curve through the points. Again, this is one period or one cycle because it continues to repeat itself on either ends, right? It's just repeats itself. Let's think about this. This is the parent function. So y equals cosine of x, you want to remember this shape. Recall that I have a maximum point, then intercept, then minimum point, then intercept, then maximum point. So for cosines, you start at the max, right, and then go through 2 intercepts, versus for sine, you start at the intercepts. Now, if this was negative, what would happen? If I had a negative out in front of the cosine of x, it would make a reflection, right, over the x-axis. So the graph would look something like this instead. Oops. So if you were sketching, you would start from the minimum instead of starting from the maximum for one period. Let's go ahead and recap the parent functions on what their graphs look like. So y equals sine of x, I'm going to have 4 intervals total and a max and a min location. For sine of x, you're you're going to have 3 intercepts going to the max first and then to the minimum. So these are your 5 key points for your sine graph. You want to remember this because we're going to graph this over and over again, just with differing x and y values. Let's do the same for y equals cosine of x. So for y equals cosine of x, again, I have my 4 intervals here, my max and my min. But for cosine of x, you start at the max, right, and then you go through the intercepts like so. So it would look like the following. So that's one cycle. That is the parent function graph or sketch that we will use. Again, notice that I have 5 key points. 1, 2, 3, 4, 5. You start at the max for positive cosine, you start at the minimum for negative cosine. Each time you cross through, right, each time you have to go through the intercepts. Do you see that you have to go through the intercepts to go onto the other side of the x-axis? So these are the forms that we're going to look at. Okay, notice here, if I were to have the b in factored form, or if I have the b in the inside of the sine factored, I have a vertical stretch by a, horizontal stretch or shrink by 1 over b, left and right shift, right, horizontal shift, and then up and down vertical shift there, right? Same thing with a cosine function. If I were to factor that b out here, right, a is the vertical stretch or shrink factor, 1 over b would be the horizontal stretch or shrink factor, h is your horizontal translation left or right, k is your vertical shift up and down. It turns out that the form without the b factored is actually easier to graph sine and cosine functions, so these are the ones that we're going to work with. Let's go ahead and list some important terms. Amplitude is basically your vertical stretch or shrink factor. Okay, so we want to know how much is your graph amplified, right? So it's really just your a value, but remember it's your positive a value, because if you have a negative, it just makes it a reflection. So the positive a, or absolute value of a, is your amplitude. Okay, the period, or one full cycle before it repeats itself of a function, is going to be 2 pi divided by absolute value of b. So it's 2 pi over b, but you need to make sure that it's positive, because it's a length, it's going to be positive in value. So your period is 2 pi over b. Okay, let's think about why that is. So normally if you have y equals sine of x, right, you have one full cycle from 0 to 2 pi. So notice that, like, I'm going to have something that looks like this, right? My one period is equal to 2 pi, right? Every 2 pi, it repeats itself. Because remember, coterminal angles repeat themselves every 2 pi, or one full revolution, or 360 degrees. Let's take a look at, for example, y equals sine of 2x. Notice that the 2 is on the inside and it's in front of x. So we have a horizontal something by a factor of something. So remember, when it's a horizontal stretch or shrink, you're multiplying by the reciprocal, because you're really dividing by 2, not multiplying by 2. So if you're dividing by 2, it's the same thing as multiplying by 1/2. So it's the reciprocal of whatever number you see. So you have a horizontal shrink by 1/2, meaning all the x values are going to be multiplied by 1/2 compared to the parent function. So that means if I have y equals sine of 2x, instead of being at 2 pi, since that's an x value, that's going to be half of where it was. So if I multiply by half, I get pi, right? So my period, the length of my one cycle before it repeats itself, is going to be pi units long. So notice here what I essentially did was I took 2 pi and I multiply by the horizontal stretch or shrink factor, right? And the horizontal stretch or shrink factor is always the reciprocal, so it's 1 over b. Okay, so that's why our period here is 2 pi over b, because what we're really doing is 2 pi, the period of a parent function, and you're multiplying it by the horizontal stretch or shrink factor, right? So it's 2 pi over b. And again, it's positive, right, because period is the length of one cycle. The next thing you need to know is something called the phase shift. The phase shift is really just the horizontal shift, like how much you're going left or right. But it has a fancy term called phase shift instead of horizontal shift when we're talking about sine and cosine graphs. Now, recall that you can find the horizontal shift by factoring out that b value and figuring out what the h value is. But an easier way to find the phase shift or the horizontal shift would be to do the following. Set the inside of your sine or cosine function and set it equal to 0 and solve for x. So bx equals c, x is equal to c over b. So c over b, or x equals c over b, that is going to tell you how much you shifted by horizontally. So that is your phase shift. It could be positive or negative, right? Positive would be when you move to the right. So it would be a horizontal shift to the right. And if it's negative, you would be moving to the left. And we also have the vertical shift, right? Vertical shift would be how much you're moving up or down, and that is going to be your d. So your d value would be the same as like k if you were to write it out that way. So d, the number that's dangling out here, that is how much you are vertically shifting either up or down compared to the parent function. So let's go ahead and recap. Amplitude is how much your graph is amplified by, right? So it's basically your vertical stretch and shrink factor. Remember to keep it positive because a negative out in front would just mean it's a reflection over the x-axis, right? Vertical stretch and shrink factor is separate. So amplitude, absolute value of A. Period is the length of one cycle, and the way you can figure this out is by doing 2 pi over b. Again, it's the length, so it's going to be positive. Phase shift is your horizontal shift, right? It's just set the inside of the function equal to 0 and solve. If it's positive, that means you move to the right. If the value is negative, that means you have a horizontal shift to the left. Vertical shift is just the number you see on the outside. If it's positive, that means you move up. If it's negative, that means you move downward.